Hey guys, so welcome to Peekaboo cracking evasive stealthy threats in today's pandemic space. So super excited to present at Quebec 2020. Been a tough year, a lot of online events and stuck at home stuff, but it's been an interesting year when it probably comes to threat actors and malwares and cyber attacks because it's been like a roller coaster ride for the last 7.5 months. Different threats keep changing. The landscape has probably changed every month or weeks, and you're in for a ride probably because I'm going to present what are the stuff that I've probably worked on, like interesting stuff. We've cracked some interesting malwares, and we've done some innovation also to stop these threats. So let's get straight into the business. I am Shyam Sundar Ramaswami. I lead the threat research group for Asia Pacific. I am a malware and a memory forensics professional. I'm a two-time TEDx speaker. I've taught classes in Stanford University cybersecurity program. I'm also part of Indian government's cybersecurity program, and I'm like a big, massive Batman fan. So I travel all the way from India to Los Angeles to watch the real Batmobiles that you see right here. And I went to Las Vegas to see all the Iron Man suits that were on display also, like a big fan. Cool. Now, all the characters, not characters, I'm sorry, all the malwares appearing in this presentation are not fictitious. Any resemblance to real malwares, living or dead, is purely possible. If you see any samples, reach out to me. I would probably love to take a look at it. But whatever you see is super real stuff that we've been working in the last 7 months. Perfect. So, what's the agenda today? So, we're going to talk about the pandemic threat landscape. We're going to talk about RAT and Agent Tesla, the two popular malwares that have been cranking up in the last 7 months. We're going to talk about their stealthy methods, how they probably operate, and evasive pandemic malware. And then we're going to do an interesting two demos today. One demo is about why we use memory forensics for analysis and not the traditional malware analysis. And other demo is probably about Cisco Umbrella's Investigate. And we're also going to talk about entropy to solve malwares. Now, and in the end, it's thank God it's over. So now everything's going to be really simple. Just don't worry about it. It's like too technical. I'm probably going to put it super simple so that everybody gets it, and it's not going to be any boring lecture, to be honest. So you can put your money on me. So, okay, let's get to the business. So, a threat has got two sides, okay? Two sides of a threat is the most important thing. Now, what are the two sides of the threat? Now, the one side of the threat is what people see today, is saying that there was a malware that got actually attacked, and then it's caused a lot of damage to our systems, and that's the news that actually is. Now, there's a second side to the threat, which we researchers usually see from the industry perspective. Now, what is the mode of the malware that actually came in? You would probably listen to the previous talk, right? About the MITRE stuff that they mentioned, saying that how does a malware gain access to the computer, what dirty stuff it does, and how it escapes or exfiltrates data. Now, that's what is most important for us. Now, we want to know how the malware is probably coming in. What are the tricks that these cyber attackers are actually following to evade security products, firewalls, antivirus engines, and how do they hide? So the hiding factor of these malwares and their patterns. Now, this is the most important thing because any stuff that we probably do to reverse these malwares, decode these malwares, figure out which domain or IP these guys are talking to, this probably goes as an intel to any cybersecurity product. So the need to get it right and straight and get the proper data is the need of the hour. Any mistake we probably make on that gives you bad intelligence to the product, gives you a bad reputation score to the product, and it probably affects the customers too. Now that's why I say threats got two sides. The side of the coin that you see is what you see, but what you do not see is the backside of the coin is the most important part. Awesome. Now, what's this? It's like the sheep and the wolf in the sheep's clothing, to be honest. So, in the last 7 months, pandemic themed malwares were doing a lot of noise. Okay, so they made a lot of noise. Now, how did they make this noise? So, the primary fact was something called small spam. Now, when you get an attachment in an email that says your insurance is expired, WHO's probably sent you a bunch of stuff, take a free test, or all those things. If you see a doc or a PDF or an Excel sheet or a JPEG, well, that's actually a mall spam. Now, how that actually works is like it's malware with a spam attachment. Okay. Now, the email looks neat and easy, but you have a document. Probably when you open the document, I'm not kidding, when you probably open the document, you're probably going to get infected the moment you open the document. Now, how does that actually happen? Strange but true. This is actually the beauty of mal spam. Now, what if I send a malware attachment directly to your email? Your firewall is probably going to catch it, right? Any attachment's probably going to scan by the antivirus engines. It's probably going to catch you real straight by the neck and say, dude, you're a malware. You're not supposed to enter the computer, and it's going to get busted. The other way that it actually evades is by sitting inside applications like free cache cleaner, document to PDF converter, all of these free softwares that we use, right? So something of the sort, MP3 cutter, and all of these things are like free softwares. That's the way the malware sits inside these applications and they make their way inside your computer. Now, these were the predominant trends that happened in the last 7 months. And this was like the entry point for all these malware. Cool. Now, what are the 2020 cyber trends that we probably saw? There was a lot of evasion, which means the malwares evaded most of the security solutions, antivirus engines, the machine learning algorithms, and it was heavily obfuscated. We'll probably talk about the obfuscation evasion in the upcoming slides. And the main fact that I probably want to cover here is confusion. It confused a lot of people, okay? It confused whether it was a malware or not. If you probably block the domain or the IP or flag it, it could probably result in a false positive. Sorry, so that was confusion. And it's probably hiding pretty massively, which we are going to cover. But what we're going to cover in the entire talk is probably about evasion, obfuscation, confusion, and hiding. Now, how were these things impacting researchers or the industry pretty massively in the last 7 months? Now, they used a lot of new tricks, but if you probably deep down check about their nature, where they probably come from, it's because of the fact that they are old actors. They reused their infrastructure, but they had new tricks up their sleeve, which we probably took time to catch it, but we caught them. Cool. Now, what you see is the box does not make any sense, but it actually makes sense. Now, what is this macro-based malware? Now, I spoke about saying that you get an email, you have a doc or a PDF, which is an attachment, right? Now, in the moment you probably open the doc or the PDF, you probably get infected. Strange but true. How? Now, how does it actually happen? So this is actually called as macros. Now, macros were created for a purpose to automate your tasks. For example, you have an Excel sheet or you have a Word doc. You have that with you because once you open the doc or the PDF, you're probably going to see formula, bar charts, pie charts to make your life easy. Now, let's take this example of the box, okay? Now you have the box here. Now, when you probably open the box, you want to have a tie that probably comes out of the box and claps its hands, right? Like a tie that comes out and claps its hands. Now, the moment you have to probably close the box, you have to wind the tie back into the box and seal the box again. Now, each time when you probably open the box, the tie has to come out and start clapping its hands. Well, now it's a pretty manual task that you probably have to do to open the box, put the tie back in it, and close it, right? Now, what if you had a function or like a formula or like a program named macro Once you instruct it saying that, dude, when someone opens the box, that the toy come back, clap its hands. When somebody closes the box, the toy has to go back automatically. To automate the task, that's why macros were probably used. Now put this whole scenario back to your Word or your PDF. You get an attachment, and that attachment probably says that your insurance is expired. Open the doc to see your balance that you need to pay. The moment you probably open the doc or the PDF or the Excel, this is going to happen. Now the box is opened, and instead of the toy coming out, it's going to talk to the internet, to a URL or an IP address, and it's going to download a payload. Now that's where the real malware comes into picture. Now, why there's no suspicious alerts raised probably by the antivirus or the IPS is because a Word document is a legitimate process, right? That legitimate process is executing something, and the malware author piggybacked on the macro, cleverly placed the script inside it, and then when they opened it, that's when the malware downloaded. Now, this is the solid trend that's been happening for like years, but it's super obvious in the last 7 months that threat actors have been using this mall spam to deliver several threats using the pandemic theme. Cool. Now, that's how basically the macro-based malware works. Now, what's the hide and seek all about? Now, usually what happens is, now when you have a document, the moment you probably open the document and do a bunch of activities, we probably call it as static analysis, right? Without running the document. So usually how do you figure out if a document is malware or not is take the document, put it inside a virtual machine or a computer that's not connected to the internet, and you monitor it. Okay, now this is like a painstaking task, right? You take the document, put it in a machine, make the document run, and once it probably runs, you probably have to monitor what happens and you study the output. Now, what if there is like the most simple technique that you probably call it as static analysis, right? Now, this is actually a showroom that everybody knows about it, right? Now, let's say if I probably want to buy clothes, I can go inside the shop and try each and every cloth, dress, or shirts or trousers and figure out if the color combination suits me or not, right? But there's also another way. Since this whole system is transparent, I probably can stand outside and just have a peep inside, saying, oh, you know what? Nothing suits me. I'm not probably going to go in and waste my time. Now that is actually called a static analysis. Now, when you go inside the shop and try out everything, it's a big process. That's dynamic analysis. You are executing everything to see what happens. But if you stand outside the shop and do window shopping, take a look at it and see what happens, if it fits you or not, that's static analysis. Now, that's exactly what we're probably going to do, right? Now, we're going to run static analysis on the document, right, that came with the attachment to see if we have any visible patterns or not. Now, you use a program called strings. You can probably Google about it, strings, right? Now, when you run strings against a file, it tells you the possible strings and the combinations or any coded functions or methods that have been called in like a plain text like this. Now, taking a look at the strings, you can probably say that you know what, this is what the malware is probably going to do. Okay, but instead, what happens in our case, since I told you this is a game of hide and seek, there were not much of visible patterns that actually happened in this pandemic malware. Only one thing that we probably observed was like probably two things, like it's a Word document, everybody knows about it because you saw it in the attachment. And the second thing is a big string. Now this is like a strange pattern. This is actually from emoted epoch, a Trojan that probably steals your passwords and does a bunch of stuff, had one good string here. Interesting, right? But in a normal day, right? In a normal sunny day, what usually happens is you'll probably see a lot of output that's probably got an IP address, a domain name it probably talks to, or the Windows functions it tries to call, like saying create a file, delete a file. You would see a lot of these things usually, okay? But in this pandemic theme malware, none, absolutely none, okay? So we ran a tool called OliVBA. You can Google about it. The OliVBA tool helps you to identify the macros. Remember, macros are the box that you probably open, the toy comes and claps its hands, right? Now, these were the set of macros, and you see the pattern that we saw in the previous slide matches to it. Something is suspicious here, right? Pretty interesting. Now, I know there's something bad inside it, but I want to know what's the bad thing inside it, right? So what I did was, now this is actually the code inside macro, the box, right? The code inside the box. Now, this is what actually activates the box. And once you open the box, it's probably going to talk to the internet. Now, in any given Sunday or any given sunny day, usually what happens here is it would be in plain text. Okay. It would be in a proper plain text where you probably see stuff like create function, call, internet, delete, execute, and all those keywords. Now, if you see a lot of these gibberish stuff, that's actually called as obfuscation. Okay. Now, we spoke about the trends that when we started the talk, saying that cyber trends of 2020 were evasive, hiding, right? Now, we saw how it is actually hiding. The second thing we probably saw was obfuscation. Now, this is what it means is obfuscation. Gibberish, random names to functions where researchers find it super hard to actually figure out what it is. Okay. Now this was actually a big task. Okay. I couldn't even see what is actually happening here, and it was pretty hard to see what was the variable that was called, what was it going on, and all those things. Now, what actually came to my mind was something old school. Okay. Now, if you remember Visual Basic Editor, right? I did it like several years back when I used to do Visual Basic coding. We used to create a farm in the Visual Basic Editor, play around with it, right? Now, what reminded me was in the Word, in Microsoft Word, you have an option under ribbons to use a developer option. So I used the developer option and I found out that these were all coded using the old age VBA stuff. Okay. Now, do you remember we used to do the checkbox, combo box, radio buttons back in like several years back, where we used to do these things and each used to have a value. Remember? Now, when we used to code, it used to display an output. That actually caught my eye. When I opened this in the Visual Basic editor, I figured out there were like a lot of these random domain names that probably matched here. Okay. Now, you know what exactly was actually happening in this case? Each of these combo boxes and text boxes had a value to it. You heard me right. They had a value to it. Now, they were telling a message. You know what happened? This was actually HHTPP, or this could be WINDO, or this should be called CALL or EXECUTE, right? Now, the legitimate words like call, execute were actually split into words so that your antivirus or your deep inspection firewalls or your endpoint detection systems do not look for known patterns. Okay, so when I decoded it and I put it all together, it actually read as Win32 process. Strange, right? Which means when you probably open your Word doc, it's going to call a URL, download a file, and this is actually going to run as a process. Super stealthy, right? So that's what we figured out. This was like a trend that actually happened for like 5 months at straight, where most of the emoted document followed the same process. Now, it probably took a while for us to solve one, and then the rest were probably easy peasy because most of the other malwares followed the same trend. That was the first stealthy obfuscated, confusing pattern that we saw in this pandemic space. Now, the second one that we probably saw was the Azerbaijan target. Now, the Azerbaijan target was also the same. They got a document from their government saying that you need to do this blah blah stuff. It came from the government of Azerbaijan. So people probably opened it. The same trick happened that I told you. Came in an email. It was a document. Open the document, macros, speak to the internet, download the malware, and boom, you're done. Now, what is the strange thing that actually happened in this case? This was actually called this poet rat. Okay. Now, sorry. Now, what they usually do is they target organizations for such attacks. But shockingly true, what happened was they target a lot of energy and power sectors. Okay. Now, energy and power sectors were heavily targeted this time. And the fun fact, basically, what happens in such cases is when you go for government level organizations, your permissions to execute is very minimal. So last time when these guys made it to the government sectors, they had the whole Python interpreter inside so that they smuggled the whole Python interpreter and able to run the malware, which is a Python-based malware. It was stealthy and deadly, but for this pandemic, the next 3 months, they changed to something called as Lua script. So they ran that. Now, if you observe something, right, this is the same macro code, but this was pretty easy because this was not obfuscated like the way we saw. Now, do you see something called as document underscore open, which means this is the macro, the box example. The moment you open the document or the box in this case, it's going to call out these bunch of code and it's probably going to talk to the internet, download a file, and then you boom done. Okay. But what is this? What is the actor's touch in this? These guys had some poetic verses from Brothers Commercial. If you see a lot of these things, these are some poetic verses. Some actors with the taste, I guess, right? That's why they call this poet rat. And this was another pattern that we probably saw. Now, this was the most interesting thing that we saw when we reversed the pandemic space, something called as Agent Tesla. Now, if you see Agent Tesla, it probably ranks the second highest threat in this pandemic space. It's nasty, okay? They steal a lot of stuff. They get into computer the same way, but they made use of something called as Microsoft Equation Editor. I'm not kidding. I'm true, okay? What I'm saying is probably 100% true. Now, this came as a Word document, but I'm sorry to burst the bubble. We tried to follow the same process for Emotet by opening the doc, looking for strings, macros. We used the visual editor. Nah, nothing helped, right? So that's like bummer moment for you, and nothing worked. Now, what exactly we found here was this was actually using a new trick, totally new trick, okay? Now, when you're not able to do stuff using static analysis, right? That's what I told you. When you run strings, when you do a bunch of interesting stuff, if you're probably not able to do anything, you resort to something called as dynamic analysis, which is what you run a file. You run the file inside a closed virtual machine, which does not talk to the internet. You can probably observe the behavior of the file. That's what we did too. Now, this is actually called as a process monitor, where you monitor the process when the malware runs. By looking at the process, you probably can say, okay, this is what the malware is probably trying to do, and you can actually locate the right stuff in the right places. Now, what we did was usually what happens is every process usually has a system process and an authentication process and your local authentication, and then your svc host.exe or your explorer process runs. Any change in the process, right? The system process should not have a child process, which means it's suspicious. You need to monitor those things. But in our case, what actually happened was everything was going good. And I saw a lot of this Microsoft equation getting, called. This process was running heavily. Okay. Later, when we found that this was done, it silently dropped a frankbond72.exe file in the roaming folder. Now, what exactly was it? Now, this is the dock. When you probably open the dock, there was no macro. There was some sort of a URL call that actually happened, which happened after this Microsoft equation editor. And then it dropped an exe inside your folder. Now, this is the real malware and not this, okay? So what happened was the Microsoft equation editor that we're talking about had a CVE, which means it had a vulnerability that these threat actors exploited. The moment you open the dock, they're going to search for the equation editor, which is there by default in Windows. They're going to check the version. If it's outdated, it's a particular version, they're going to use it to exploit, open the back door, and then push this malware in. That's how the agent Tesla probably came in a picture. And we also saw something very interesting with the Franco file was it was actually asking for the cursor position. Now, why would a malware probably ask your cursor position? Strange, right? Strange, but true. Now, this is another evasion technique. Usually, people upload the files to sandboxes, okay? Sandboxes are automatic boxes that process your malware and gives you an output. It's all automated. Now, usually what happens in a sandbox is there's no user interaction. It picks up, it has a bunch of scripts, it runs and gives you an output. Well, let's take, for example, in my sandbox, just watch my mouse pointer. It's going to stay here. Now, even after 15 seconds, 40 seconds, 80 seconds, this cursor is probably going to be the same. Now, if I'm probably a user who's analyzing the file, I keep moving my mouse, do something over the sort, right? Now, that's what the malware is probably looking for. It's going to check if the cursor's position is going to remain the same after 15 seconds. And if it's yes, then probably it quits. And if it's no, it's probably going to run. This is a classic evasion technique used by malwares. And these were probably used heavily in pandemic. And also, they checked for adapters, disk information, and language settings. Now, what are these? They checked if it's got a real internet connection or like a VirtualBox internet connection to see if we were running it in an environment, trying to study the malware. And the disk information was also checked if it's less than 2048 of RAM, then probably it's a VirtualBox. And it also checked for language settings where it was probably checking that if you are from Russia or from any other country, if you're from a particular country, the malware sample does not run. Interesting, right? Now, before we probably head into the interesting demo, this is the last of the trends that we probably saw, and then we're probably going to go full guns blazing on hands-on stuff, okay? Now, what we probably saw here was the rise of encryption. Now, usually when a malware probably talks to the command and control, like the mothership, right? There are a bunch of domains that gives instruction. The attacker gives instructions from a domain or an IP to the malware to do next. What to do next? I stole something, boss. What do I do next? So the instruction comes in via a command and control channel, which is a domain or an IP or a URL. Now, usually by looking at those things, you can decode what exactly it's doing. If you sniff the traffic, you can probably see what's happening. Now, in something called as blinding can, right, this Trojan, the whole process was basically encrypted. The C2 instructions were encrypted, and usually malwares have something called as a configuration file, okay, a C2 configuration file. The server address and about those were four levels of encryption there. There were an encryption to protect the other layer, and the other layer, like Inception movie. Okay, it's pretty smart and strange, just like heavily encrypted. Cool. Now, what exactly happened was whatever we saw was incremental, right? We used a tool approach, then our tools failed. We used a non-tool approach, and then when we played around with the samples, the malwares probably detected us by saying that, dude, you're busted, right? I know what you're doing. So they failed to run. Now, what's the one way that I probably used in this pandemic space to figure out what exactly the malware's true behavior was? So you had to play a little cheater game to cheat the malware to run. Now, how did I do it? Well, welcome to memory forensics. Okay. So I used a concept called as memory forensics to play with these complex malwares. Now, what exactly is memory forensics? Now, whatever we probably saw was malware that had evidences, dropped files, DLLs, and a bunch of stuff in your computer. Okay. Now, what if that's because if they drop the files or the DLLs, researchers are probably going to take it, study it, understand the pattern, and probably going to come back strong to stop the malwares. Now, why don't we make the researchers run for their money, right? Let's make them run in circles for time so that they get tired. Now, what these threat actors usually do is, you saw my file, right? You saw this file that I showed you. Yeah, you saw this file, right? That I showed you. What if this file was probably dropped on the disk? Now, what if it was dropped and unpacked inside the memory? You will never have the evidence of it, and you can't even study the evasive nature. Now, that's where we probably use memory forensics. Okay, now what we're going to do is we're going to run the malware sample, okay, inside a virtual machine which has got no internet connection, and then we're going to acquire the entire memory dump of the machine and then traverse through it. Now, how can I traverse through it? You have a lot of uh, options like volatility, recall, bulk extraction. These are some popular tools that give you some really, really interesting stuff for you to do. Trust me, super interesting stuff that they allow you to do. So what exactly did I do in this case? Okay. Now, what exactly happened was when the malware, some of the malwares are super evasive. Even when you do using tools, what they actually did in my case was something sneaky. Okay. They did something like super sneaky stuff. What they did was they had the list of tools that we usually use for malware analysis, and they also check for the process name. If it finds the tool of that sort, it's probably going to stop running. Strange but true, right? So that actually happened to me when I ran the malware. Now, why memory forensics is explained, right? You can hide, but not in the memory. You have to run. The more you hide, the more you probably stick out. So I'm going to use some tools like volatility and recall. Now, there's like one smart trick that I actually did. Now, even if I run some of the famous tools in malware, it's going to probably find out. I resorted to a very smart technique. Okay, I'm going to have two machines. Okay, now usually what happens in Windows is when you hibernate or put your computer to sleep, it takes 3 seconds or less than 3.5 seconds to put all the process that was probably currently running to a state and save it in the memory, and then it goes to sleep. Now, when your computer comes back from sleep, when it wakes up, it's going to restore the list of process that it actually was saved in the memory, and then the malware probably decides to quit or not. Okay. Now, sometimes malwares will not wait for that signal. Like when the system probably hibernates, they have no other choice. They can't kill the process. They're still running. Now that's what I'm actually going to do. I'm going to put the malware, run the malware, let the malware run for a while, and suddenly I'm probably going to put the system to hibernation mode, acquire the hibernation sys file, which is there in Windows, and then I convert the file to memory image, and then I run my tools against it. So the malware has to run, it's got no other choice. Now this is the trick I'm probably using. I have a machine that's a Linux machine, and I pass a bunch of WMI commands, which is Windows Management Instrumentation commands. When I pass these bunch of commands, it's going to invoke the sample, run the sample, and it's also going to do the hibernation mode, get the file back, and then we're going to analyze it. Now, this is how a WMI command looks. Uh, it connects to a system, it's got a password, and then it's going to host and it's going to run a bunch of commands. I'm probably going to execute the sample, and then I'm going to invoke the process. Now, sometimes there are very rare cases where malware looks for VM adapters and also looks for physical memory less than 2048, and then it probably quits. So that's how it usually happens, but it's super rare, like 0.23% of malwares probably do it. Pretty rare. So let's see how I probably busted this activity by running the the memory forensics and get the sample. I think you can someone unmute and see if you can see my screen again, guys? Do you see my demo screen?
Yes, we saw it and we're seeing it.
Awesome, thanks. Okay, it's always a double check question. So, okay, now what exactly I did in this case was I used, this is the Hibernation file that I acquired from the memory. And I know it's a Windows 7, and I'm actually using an image copy command to convert it to a real image. Now, once I probably do this, it's going to give me an image file. Now, this is the the hibernation file that's going to be a sys file, sits in your Windows during the hibernation, and you can acquire it. And I'm giving a profile for volatility to understand, saying that this is a Windows 7 machine. So don't search for the profile, tell it's Windows 7. And I'm going to use an image copy command to change it to an IMG, because volatility can parse raw and IMG images. Now, once it's a big process. I skipped some of the steps because it's probably going to take a while for it to run forever. Now, when I ran it, what actually happened was it gave me a beautiful image. Okay, it's a big process, so I just cut short some steps, and it gave me a big list. Now, what I'm exactly going to do is I'm going to say, dude, you got the image now. I have the profile. Let me run the list of process. So there's a command called pscan. I ran the list of process. When I run the list of process, it gives me the process that was running, that actually died, and that was actually in the system. Now, usually why we do this is because malwares, if you do a normal process check in Windows, it's going to show the process that basically is running, not the ones that exited, died, or is a zombie process. If you probably do this from the memory directly, you can find out the history of the process. You can nail your enemy damn straight, saying that, dude, I know you ran and you were hiding. I caught you. Now, the next thing we're probably going to run is to see uh, if probably there are any interesting DLLs. Okay. Now, usually why I'm saying DLLs is when a process runs, it's going to drop an EXE or a DLL. A DLL is also an executable. Usually there are two DLLs, signed and unsigned DLLs. Signed DLLs, you'll see Microsoft, VMware, all those signatures are there for a signed DLL. You can identify if it's a company DLL or not. Okay, but the unsigned DLLs are usually malware DLLs. So if I run the DLL command, I can probably figure out which is the bad DLL, which is a badly named DLL, which is a DLL that probably sticks out, stands out, which does not even look like a real DLL. So from this, probably I can figure out what's the bad DLL, and you can convict saying that, dude, you're the malicious DLL that actually happened to me. And the other thing that you can probably see is using a PS tree. This is like a super command that helps you to, look at the entire output and say, what command launched the process, from where it launched, what's the process. That helps you to nail down, to go inside the particular location if it's hiding, and then probably stop the malware. I didn't have one more thing, but I didn't actually add it. The next you can probably see is the connection scan, which means which process spoke to the IP address and what the process is probably all about. That gives you a clear picture saying that this was where it was loaded, it's in the memory, this exited, so that you can hide the stealthy process. Now, that was malware analysis, memory forensics probably for you. And sometimes what actually happens is you can use the same memory forensics to carve the memory. When sometimes we acquire machines from criminals at times, some people who use pornographic content, right? Minor pornographic content. When we catch some people, they would probably wipe out stuff from the computers. Such memory forensics helps us to look at the passwords. What did they search? This is heavily used for murder cases and some divorce cases where probably the wife tried to kill the husband or the husband tried to kill the wife, so on. So you can probably figure out who served what. And there's a tool called bulk extractor. If you have the same memory that I showed you, right, image, you can probably run through it and figure out what they were surfing, what are the passwords that they used, what are the URL searches, the words that they used, the IP they searched, and all of this. This is called as carving strings from the memory. Okay, this is probably the last part of the talk, the master stroke. Okay, now this was a very dangerous trend that we observed throughout like the last 3 months of the pandemic space, which was we saw a lot of Japanese themed malwares. Thanks to cyber reason for the image credit, I couldn't find the sample, but I started playing around with it when I read a lot about this, but I was able to get only the URL and not the sample. So what happened was there was a Japanese themed same trick, right? You open this, the macro is going to open, call the URL, and do a bunch of stuff, right? Now we saw in this scenario that there was no exes dropped. Okay, there were no exes dropped. We just saw an image file that was probably running. This is being taken down, and then we saw an image that probably sat in the computer and not an exe. Strange, right? What was it? Why is an image being downloaded by the document? It looks like a malware. Now that's where the rise of steganography. Okay, they use something called as invoke PS. Now what actually happens is when you open the doc, it's going to download an image file. The image has got a PowerShell or the malware script inside the image hiding in the pixels or somewhere. Okay, now there's going to use a PowerShell to call the file. Now it bypassed all the scanners that we know so far. Now this was the same trend, and also checked if you're Japanese, if you're not from Japan, it's probably not gonna run the sample for you. And we saw the same thing with Sodinobuki ransomware. Sodinobuki ransomware was the one that probably started the whole thing. Now it confused the investigators, right? I told you confusion, right? Where they had 1,000 domains inside the config file, and they tricked everybody. So usually what happens in the community is when you see a bunch of domains in the config file, you're going to go block it. And we did the same thing. It actually raised a lot of false positives. None of the domains were compromised. They just misleaded people by putting the whole bunch of domains in the config file. They ranged from fashion industry, hospitals, nuclear power plants, and a bunch of stuff. And then we observed the same thing when we saw the traffic. Thanks to Brad's traffic analysis for the traffic capture, he had captured it. So when we used the traffic capture, we figured out there was a lot of PNG images similar to the Japanese theme. And then we put those URLs in VirusTotal, and I put those things in VirusTotal to see. Everybody said it's clean. So it escaped all the antivirus engines, everything smartly, and none of them detected it. And when we played around with it, these were the bunch of URLs that were spotted. All of them were GIF and PNG files. None of them were marked bad. And usually what happens with image files is there's something called as an EXIF header, okay, where they have the metadata of the image, image name, image size, and JPEG, and all those bunch of stuff. Usually they keep the malware code inside the model or somewhere here. We tried looking at it, but bummer, nothing. What instead we found using this was actually exfiltrated phone numbers, exfiltrated data from commands, system command and control commands. Everything was hidden inside this very picture. That is basically a bigger stigmography. Now, how do they stop this? So now this was actually my black hat concept. I gave an interview also on that. You can use entropy, right? Entropy is where you have an ice cube. If it ice cube is intact, it's low entropy. If an ice cube melts, it's a higher entropy, right? That's Shannon's entropy theory. Now you can use the image trailers as a section in the image, post that anything or any piece of code you find, it's malware. And you can also use deep learning or machine learning to check the pixel level occurrences of the pixel numbers. Anything that's wary or noisy, it's probably malware. Now, I have a quick demo on the Cisco's Investigate. Now, this is the Cisco Umbrellas Investigate. Now, of the whole talk when I did, right, I had a lot of evidences of domains, IPs that I found. Now, you need to make sense of the data that you investigated. So Cisco Investigate does a brilliant job here, okay? Now, I use this, this is my Swiss Army knife. I use it day in and day out. not just because I work in Cisco, but it's very handy for me. Okay, it's got a bunch of algorithmic capabilities that makes it stand out. So what I did was I put this domain name. This was from a command and control server, and I ran the domain with my investigate. Okay, now the investigate basically tells you if the domain's how does the domain looks. It says it looks risky, and it's got a bunch of meaningful information that actually says that the domain is medium risk and says it's got a geopopularity score. Now, what's the geopopularity score? It tells the pattern of the domain, lexical score, a keyword score, which probably means keyword score means the randomness of the numbers, the name, the letters, the domain, which could probably compare it against the previous known attack patterns and then gives you a score. The second thing is the TLD score that it probably uses. Now, TLD score is nothing but if the domains probably .com, XYZ, bin, bis, these are bad domains usually. So it also checks against that and probably tells you like how bad this probably is, and also gives you a lexical comparison saying, dude, okay, this domain's actually bad. Now that's the one section of the indicators that your investigate tells you, but there's got a lot of other information that it also tells you. Now, do you see the pattern here, right? This is actually called as the DNS pattern, okay? The spike pattern. There is also something called as content category. If you see something called as parked or healthcare, you probably know that this domain is a fraud domain. Somebody's registered the domain a wrong name and you can suspect it. But there are no content categories here. And you see a sharp, massive spike here. Now, this probably tells you a beautiful story where if it's dormant and suddenly sharp spikes in the DNS queries, then that probably means that the domain is super bad and it's trying to call out to a bunch of places, somebody's accessing it, and the domain is an attacking domain. So this is one indicators that helps you to block a domain, and analysts or researchers probably make a decision out of it. See, it's been dormant all this while and suddenly shot up massively. This is also compared with the previous patterns that we've had so far and then makes a decision based on it. Okay, now that's the timeline part. And then we have something called as the name servers, if it's a known name server, or the geographic pattern, or where the requests actually coming in. And now this is the best part. We are telling that, dude, this domain name is known for talking to these malwares here, and they have a history of talking to Trojans or malwares. When you probably click on this, it's probably going to give you a good score saying that looks like this domain's bad. I'm probably going to come back to that in the end. It says this domain is probably bad because it's talking to known malwares. We'll come back and investigate that. But before that, it gives you a lot of meaningful information like ASN, security features, and the list of URLs this domain's hosting. By just looking at the pattern, you can probably tell if it's a bad domain or like a malicious pattern. It's got patterns like invoice and all those things. Now, the most important part of the demo is co-occurrence score and related domains. Now, investigate gives you a very smart way of saying that, dude, I think somebody accessed the domain that you see here in the picture either before or after this domain. In some way, these domains are probably connected to each other. They can be a spam ad server or a command and control server. That's the co-occurrence score. You probably know the user visited the domains before and after of these 2-3 domains are connected in some way. And related domains is also to say that if it's got some related content towards it, if this domain is similar in nature, and all of these things that it probably says. Now, the important part I was saying that the hash that we saw, right, the malware hash, I probably want to see if it's related to this domain. Now, this hash has got a very bad score, and investigate gives a combination of output from threat grid, which actually says that it's making outbound communication. It's got a script or URL. It makes a HTTP command, a whole wealth of information. Now, the best part is it tells you what the sample's trying to do, and also the domains it probably contacts. Okay, you saw the pop caches, talking to the pop cache, which is a similar domain to what we were observing in the picture. Now, it also tells it's the associated samples, any artifacts that it probably dropped. So this gives you a holistic, massive investigation technique. You can also put an IP into it and see what's bad with the IP, and we'll block it for phishing. And it probably says that this is associated with phishing, and there's a bunch of domains that's associated with it, and so on. Overall, when you have a domain, when you put it in, it gives you a wealth of information to connect the dots of your investigated IPs or domain names that you obtained from an investigation to make a real good sense and visibility for your analysts or your researchers in an organization. Because visibility is the big key thing for any investigation. So, what I've been doing in the last 7 months, protecting the internet, doing all these things, saving the world, and reading all these interesting patterns. That's what we've been doing. And that probably comes to a conclusion. I hope you guys loved the presentation. I hope it was not boring. That's about the peekaboo part where we played hide and seek for the last 45 minutes. Thank you, ladies and gentlemen, for patiently listening to me. I hope you guys loved it. Any questions? I'm up for questions. I love questions.
Okay.